Now I'm going to go over some examples of converting from binary to decimal. It's much easier to do this if you have a piece of paper and a pencil on hand so that you can go over this with me. So if you don't already have that, you should probably do so now. Start out by writing the number that you're going to convert. So the number that I'm going to use is 10101. If you don't already know your powers of 2, you should go ahead and start writing 2 to the 0, 2 to the 1, 2 to the 3, and so on under each value in the binary form, starting from the right side. Then you go 2 to the 0 equals 1, 2 to the 1 equals 2, 2 to the 2 equals 4, 2 to the 3 is 8, 2 to the 4th is 16. And if you don't really know those numbers off the top of your head, you could just be like, what's 2 times the previous value that I just wrote down? Assuming that you know the value before it was correct. Then you go, what is the binary value? So starting from the left, we'll do 1 times the decimal value, which is 16. So that's 16. And then you're going to add the next one. So the next number is 0. Multiply that by 8 and you get 0. And then you add 1 multiplied by 4, which is 4. And then you add 0 multiplied by 2, which is 0. And then you add 1 multiplied by 1, which is 1. And you get a total of 21. So 21 is the decimal value or base 10 version of 10101 of binary or base 2. A simple trick that I noticed is if there's a 1 in the 2 to the 0 position in binary, you know that the number is going to be odd. So if you did your math and you end up with an even number, then you need to look back at the values that you wrote down when you wrote 2 to the 0, 2 to the 1, and so on. Oftentimes the mistake is writing 2 to the 1 instead of 2 to the 0, and starting with a value of 2 instead of a value of 0. Now I'm going to show you an example of how to convert from decimal back to binary. So say you have the number 45 and you want to convert it to binary. What you need to do is write out the position values. So instead of starting with the binary values like you did from converting from binary to decimal, start out with listing position values. So what you need to do is start with the position value closest to 45 but less than 45. So that first value is 32. And then you're going to go all the way from 32 to 1. So you're going to have 32, 16, 8, 4, 2, and 1. And what you need to do is subtract the closest value to 45, which I just said is 32, from 45, and then put a 1 above it. And then what you have left is 13. And then you know that 13 is less than 16, so you put a 0 above the 16 position. Then you go, well, okay, is 8 less than 13? It is. Great. So I'm going to put a 1 above the 8 position and subtract 8 from 13, which gives you 5. And then you go, is 4 less than 5? Yes. So I put a 1 above the 4 position and subtract 4 from 5. And that leaves you with 1. And then you go, is 2 less than 1? No. So I'm going to put a 0 above the 2. And then you go, is 1 less than or equal to 1? It is. So you're going to put a 1 above the 1 position value. And then you end up with a binary number or base 2 number of 1011101.